Today we're going to focus on factoring using greatest common factors. First, let's talk about GCF. The greatest common factor is the greatest factor term that divides two numbers. So some steps to determine GCF is first to list the prime factors of each number, then to multiply those factors both numbers have in common, and that'll give you your final GCF. Let's try this for example. Let's try 15 and 25. So, once again, we're going to start with our prime factorization. 15 is 3 and 5. Those are both prime numbers, so I can stop there. For 25, it's 5 and 5. So now, we need to multiply those factors that they have in common. So let's look at those factors they have in common. See 1, 5 and 1, 5. So, they only have a 5 in common, so the GCF would be 5. We'll try some more examples on the next page. Let's look at this first one. Remember, our first step is to write the prime factorization of both numbers. So we have 18 and 64. I'll start with 18. So someone might say 2 and 9, someone might say 6 and 3. Either way, we're trying to get to the prime factorization. So we're going to keep going until we have all prime numbers. 2 times 9. And the numbers that multiply to equal 9 are 3 and 3. Here we have prime factorization. 2 times 3 times 3. Now let's look at 64. I'll put 8 times 8. Some of you might have chose 2 times 32. Here we have 2 times 4 on both sides. And since 4 is not a prime number, we know that multiplies 2 times 2 and 2 times 2. So in total, we have 1, 2, 3, 4, 5, 6 2's. I'll write 2 to the 6th power. So all they have in common is a 2. So our GCF for 18 and 64 would equal 2. Try number 2 and 3 on your own. Let's look at finding the GCF of two terms. So first, like we did before, we're going to determine the coefficient of each term. So once we determine the coefficient for each term, here we have 14 and 21. Then we're going to find the GCF. So once again, if you remember GCF, prime factorization, this is 2 times 7. This is 3 times 7. So our GCF would then be equal to 7, because that's the only factor that they both have in common. Then our next step is to look at the variables, which brings us to step 3. This step tells us to find the smallest exponent of each variable. So let's look at the variables. We have j squared and k to the cube power, and we have j. So 2j's here, 3k's here, 1j here. So what they have in common is 1j each. So our GCF of our variable is equal to j to the 1st power. Now we can write our final answer. That combines our GCF of our number and our variable. So we have a GCF of 7j. Let's try some more examples on the next page. Let's try an example together. The first step is to identify the coefficients. So for number 1, our coefficients are 102 and 51. Now let's do the prime factorization of these. Let's start with 51. I'm going to start with 3. 3 goes into 5 one time. 5 minus 3 is 2. We have a remainder of 21. 3 goes into 21 7 times. So we see that 17 times 3 is equal to 51. Let's try 102. I'm going to try 2 because I'm pretty sure 2 goes into 10 5 times. And 2 goes into 2 one time with a remainder of 51. And I see that 51 was my other factor, and the prime factors of 51 are 3 and 17. So they have 3 and 17 in common. Multiply those two together, and I get my GCF, which is equal to 51. Now I need to look at the variables. So we have k squared, m squared, and k to the 4th m. So look for the smallest exponent. So if I start with my smallest exponent, that's k squared and m, because m is being raised to the first power. So my GCF of my variables is equal to k squared m. So altogether, I have a GCF of 51 k squared m. Try the next 3 examples on your own, and we'll go over them together. Factoring using GCF uses 3 steps. 1, determine the GCF of the given terms. 2, factor out that GCF, and then rewriting the polynomial with the GCF on the outside of parentheses and the factored part inside. So let's start by figuring out the GCF. Remember, to determine the GCF, first we're going to look at the coefficients. So the prime factorization of 16, we'll say 4 times 4. This gives us 2 times 2 and 2 times 2. So we have 2 times 2 times 2 times 2 with x squared. And here for 12, 2 times 6 or 3 times 4, whatever you prefer. 6 is 2 times 3, so here we have 2 times 2 times 3x. And remember, we're going to go back and we're going to circle what they have in common. So there's 2 2's here, as well as here. And then the variable with the lowest exponent, which would be this x. So let's go back, and we have a GCF of 2 times 2x, which is actually equal to 4x. So I'm going to rewrite this with the problem. We have 4x on the outside. And what am I left with? 4 times what number equals 16? So I know 4 times 4 equals 16. X times what would give me x squared? I know a x, so 4 times 4 is 16. X times x gives me x squared. Minus 4x times what would give me 12x? And I know 4 times 3 equals 12. So this would be my final factored form for 16x squared minus 12x. Let's try some more examples on the next page. Let's start with this example. So remember, our first step is to find the GCF of each of the given terms. So let's start with the coefficient in the prime factorization. So here we have 12. You can put 2 and 6 or 3 and 4. Put 3 and 4. 4 is not a prime number, so the factors of 4 are 2 and 2. So here we have 2 times 3, x to the 5th, y to the 3rd. Let's look at 18. You can put 9 and 2 or 6 and 3. I'll start with 6 and 3. My factors of 6 are 2 and 3. So I have 2 times 3 times 3. And our variables, which we have x cubed and y to the 5th power. And last, let's look at the last term, which we have negative 3x squared y. So our prime factorization of 3 is just 1 and 3. So we have 1 times 3 times x squared y. So we're going to go back and we're going to look at the common factors that they have. So the only common factor I see is a 3 for each one. And then I'm looking at the variable with the lowest exponent, which here is x squared and y. So our GCF would be 3x squared y. Now another way to do this would be to divide it out. So what I could say is I could say 12x to the 5th y cubed divided by 3x squared y minus 18x cubed y to the 5th divided by 3x squared y minus 3x squared y divided by 3x squared y. So now, once again, remember I'm pulling out my GCF in the front. And then in the parentheses, 12 divided by 3 would leave me with 4. X to the 5th over x squared. Remember, we're subtracting the exponents. So 5 minus 2 would give me x to the 3rd power. Y cubed minus our invisible 1 here would give us y squared. Minus 18 divided by 3, which we know is 6. X cubed divided by x squared, so we subtract the exponents. 3 minus 2 gives us x to the 1 power, which we can just write as x. Y to the 5th power divided by y to the 1st power. 5 minus 1 gives us y to the 4th power. And last but not least, 3x squared y divided by 3x squared y leaves us with a 1 at the end. And this would be our final factored form. Let's try one more example together. So let's look at this example together. We have 22, 14, and 18. Now, I know for a fact my factors of 22 are 2 and 11. And no, 11 doesn't go into 14 or 18. So right now I can automatically say that my GCF is equal to 2 so far. But let's look at the variables. So when we look at the variables, we have x to the 5th. So x to the 5th here. We have y to the 7th. Then we have x cubed, y to the 8th. And x to the 6th, y to the 4th. So our smallest power for our variable x is x cubed. And for y, it is y to the 4th. So our GCF would actually be equal to 2x cubed, y to the 4th power. So I can rewrite this as 2x cubed, y to the 4th. And let's decide what I have left inside. So 22. I know that 2 times 11 equals 22. So my coefficient is going to be 11. And let's look at my variable. I have x to the 3rd, but I need x to the 5th. So I need x squared, because x times x with the power of 3 and a power of 2, I'm going to add my exponents. So 3 plus 2 gives me 5. And I need y to the 7th. So I have y to the 4th on the outside, so I need y to the 3rd on the inside for this first term. For the second term, 2 times 7 equals 14. I already have an x cubed outside the parentheses, which is what I need for my second term, so I don't need an x variable there. But I have a y to the 4th on the outside, and I need a y to the 8th, so I'm going to add a y to the 4th here. And last, 2 times 9 equals 18. I need an x to the 6th power, so I need to add an additional x cubed here, because 3 plus 3 equals 6. And then I already have a y to the 4th on the outside, so that finishes my factored form with my GCF on the outside here, and the rest of the terms that need to be multiplied to equal our original values from our problem. There are some examples for you to try on your own on the next page. Here are some problems to try on your own. Remember the steps. First, find the GCF of the given terms. Then factor that out and write the rest left in the parentheses on the inside.